today to announce the largest acquisition program in the history of the Department of Defense.
Roger, copy.
The Joint Strike Fighter.
And just for the record, pilot, yes, you are my hero.
In the skies over the Mojave Desert, a battle of X-planes has begun.
That looks good.
Over the next year, 2 different planes will take to the skies again and again on a relentless quest to be crowned the fighter of the future. Perhaps the last manned fighter the U.S. will ever build.
Oh, it smooths out beautiful. This is fun.
Great, it was super, yeah. Thank you very much.
So awesome.
Oh, it felt great.
We're gonna fly the out of this airplane and just kick every day. That's what it's all about.
It's all part of a top-secret competition, locking 2 of America's aerospace giants in a furious engineering dogfight to the death.
You couldn't have a more interesting competition. 2 very different companies and 2 very different designs. Conservative heavyweight against a radical newcomer.
We got a hell of a smart team, so let's go figure out how to make it work.
Whoa!
There's never really any time to relax.
Would I like to be further ahead? Yes. Would I like to be farther done? Yes.
I think we truly believe that we've got the right vehicle for the customer.
It's starting to look like an airplane. That's what's really neat about it.
Oh, I see a future contract.
Well, that too.
Not just any contract, but the most lucrative contract in military history. At least $200 billion.
Steering is off.
And the winner won't be just any fighter. It will need to land on a carrier, evade enemy radar, hover like a helicopter.
But trying to build a fighter that can do all 3 is a tremendous challenge.
It's not a natural thing for a jet airplane to do.
Come on, Simon.
Experimental new designs come with their share of risks and failures.
402 left to the downwind.
But now, the U.S. military desperately wants a winner. Claiming that aging fighters and shrinking budgets threaten to undermine its command of the skies.
Going to 76.
Will a one-size-fits-all fighter, a Joint Strike Fighter, work for the Air Force, the Navy, the Marines? Will it rescue them from the death spiral of defense costs? With unprecedented access from the Department of Defense, Nova's cameras take you into the U.S. military's most classified facilities. From the beginning to repeated trial and error.
Can I reset? Negative. We're recommending we abort.
The original design wasn't gonna hack it.
How much effort is ahead of us to make it work?
Watch 2 teams struggle to get their daring ideas off the drawing board and into the air.
The Joint Strike Fighter will be the world's premier strike platform. With a decision to proceed now made, it is now appropriate to announce the winner of the Joint Strike Fighter competition.
In the end, only one winner takes all. In the Battle of the X-Planes. Up next on Nova.
Major funding for Nova is provided by the Park Foundation, dedicated to education and quality television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support Nova.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you.
Inside this bag is the future of American fighter power.
There will probably never, ever be another program as complex as this or as big as this when you start talking about dollars.
It's called the Joint Strike Fighter Program. For 5 years, the JSF has held a competition between two titans of aerospace to see who will build the next generation fighter. It's a prize worth up to $200 billion. And the winner's name is in the bag.
The winner of the JSF competition is going to dominate the fighter aircraft market, not only here in the United States, but worldwide.
Fasten your seatbelt and put up your tray table. Nova and the Department of Defense have cleared you to enter places where cameras have never gone before. From secret installations to the cockpits of the latest experimental fighters, you've landed in the classified world of the X-planes, both high-tech and handcrafted, where pilots fly into the unknown with just you by their side. This is the battle to build the fighter of the 21st century. In the first strike in the war on terror, fighters are the frontline warriors. Navy fighters joined squadrons from the Air Force and the Marines to attack Taliban and Al-Qaeda positions in Afghanistan. These aircraft play a key role in routing the enemy, just as they did in the Gulf War in the early 1990s. In fact, some of the fighters are literally the same planes. Built in the 80s, designed in the 70s, to fulfill Cold War objectives from the 60s. The most important weapon in America's arsenal is based on ideas almost a half-century old.
Our airplanes, they're wearing out. They're tired. 30-year airplane, still a great airplane, serves purpose as well, but it's old.
These aircraft in the future battlefield, they're going to be a bit like dinosaurs. Not just in their sort of physical age, but their electronic capability. They may not be survivable.
We now have to go to higher altitude instead of lower altitude. We need to make ourselves as small as possible from a radar perspective. We have to do the same job, but the world has changed.
Almost all of America's fighters will one day wind up here, at the boneyard at Davis-Monthan Air Force Base in Arizona. Old generals may fade away, but old fighters are cannibalized for parts. The Air Force still relies on thousands of these. The venerable F-16. But the F-16 is past its prime. In the age of stealth, this fighter shows up on radar the size of a small, flying house. This is an F-18, the mainstay of the Navy. But Navy planes get old fast. The controlled crash, known as a carrier landing, and the rapid acceleration of a catapult launch will eventually create irreparable stress fractures and send them all here. This is the subsonic AV-8 Harrier jump jet, flown by the Marines. While it remains the only successful vertical landing fighter, it dates back to the British invasion of America by the Beatles. Though later refined by McDonnell Douglas, by any measure, the Harrier is ready for retirement. The goal of the Joint Strike Fighter program is to replace all of these: the F-16, the F-18, and even the vertically landing Harrier.
It is absolute vital necessity to have not only a replacement airplane for the older airplanes, but to have an airplane that's a 21st century airplane to meet the needs for tomorrow.
The plane for the 21st century, at least for the Air Force, would appear to be already here. The new F-22 Raptor, scheduled for deployment in 2005. The Raptor is the ultimate fighter. So stealthy, its radar signature isn't much bigger than a bird. And it can fly at supersonic speeds longer than any other fighter. And that means it can strike deeply and invisibly at an opponent. But the Raptor has a huge vulnerability that the JSF program must overcome: a giant price tag. Each plane costs about $100 million.
The F-22 is a spectacular airplane. The problem is it's expensive. And that means the Air Force will never really have enough of them to attack the many and varied small and large targets that make up the modern battlefield.
The F-22 is just the latest example of a trend that goes back decades. Each new generation of fighters costs more than the last, so fewer are purchased. Ever more expensive fighters in ever decreasing numbers. In defense circles, that's known as the death spiral.
Where the death spiral could lead is the prediction that in the year 2054, the U.S. defense budget will only buy one airplane. So the Air Force uses the airplane in the morning, the Navy uses it in the evening, and the Marines, unfortunately, only get to use it every leap year on the extra day.
So that is the JSF's mission impossible: to break the death spiral by coming up with a new fighter that costs a third of an F-22, replaces all of these, and meets the needs of the Air Force, the Navy, and the Marines.
They absolutely said, you'll never pull this off. Impossible.
In the past, the fiercely independent services would have fought for their own weapons programs. In the 60s, when the cost-cutting Secretary of Defense, Robert McNamara, forced the Navy and Air Force to use the same plane, the F-111, the joint program was a resounding flop. But these days, with smaller post-Cold War budgets, the spreadsheet is mightier than the sword.
The Joint Strike Fighter program was a huge leap of faith for the services. The enabler, though, was they didn't have any choice. They knew that they had to modernize their fighter force structure, and the funds were not available to do that.
With no other options, the effort to design the Joint Strike Fighter begins. And almost immediately, there's a disagreement. The services can't even agree on the number of engines. The Navy's F-18 Hornet has 2 engines for safety. If one goes out, you don't have to ditch. But 2 engines are a deal killer for the Marines because of their weight.
You cannot build today a 2-engine vertical short takeoff landing airplane. So the Navy wanted 2 engines. Marine Corps had to have a single engine, and the Air Force wanted a single engine because it was much more affordable, and they don't have it. They're not out over the ocean at night all by themselves like we are.
The decision hinges on how dependable one engine can be.
Steady state 255 started.
After talking with jet manufacturers, the JSF team ramps up the specs for engine reliability. Rear Admiral Steidel convinces a reluctant Navy to go with just one.
That was another piece that was necessary to pull the program together. So without that, we could not have a common production line.
I think the effort that's gone on here to create a joint requirement is astounding, and it's really it's what's allowed the program to get where it is, and it will be what allows the program to continue, because if the services keep saying we all agree what we want and we want this aircraft, then it will happen.
Even with everyone on board, there's rough air ahead.
We know how to build a stealth fighter. We know how to build a long-range, agile fighter. We may even have a good way of building a fighter that can land and take off vertically. But trying to build a fighter that can do all three is very, very difficult.
The Pentagon spent over $3 billion in research to see if it was possible. And the answer? Sort of.
The airplanes are not the same aircraft, but the building blocks are the same building blocks for the most part. Same engine, same major avionics. In fact, it's not important to have every piece part the same, but the expensive parts or modules. Through the life cycle of the aircraft, there was the potential to save $60 billion. And that's a lot of money in anybody's calculus, even in the Department of Defense.
With the services in agreement about the requirements, the Joint Strike Fighter program launches a competition for innovative designs for the new, affordable family of fighters. Like a high-stakes game show, only 2 contractors can make it to the final round and build test planes. With billions on the line, U.S. defense contractors hold their breath as the Pentagon announces the 2 finalists for who wants to build the next generation fighter.
These contractors are Lockheed Martin and Boeing.
The announcement sends shockwaves through the aerospace industry, dealing a death blow to one of the most respected names in aviation. McDonnell Douglas, a company with a fighter legacy that seemed to guarantee a spot in the final round, doesn't make the cut. The impact for the company and its employees is devastating. Within 2 years, McDonnell Douglas is sold to Boeing, one of the JSF winners. A world leader in commercial jets, the Seattle-based company is seen as an unlikely contender in a fighter battle, for good reason. Boeing's last fighter was built in the 1930s, the P-26 Pea-Shooter, a fighter from the age before jets, before even a closed cockpit.
Boeing hadn't built a fighter in a long time, and I think early on, Boeing was considered literally a dark horse in this competition.
But the Boeing acquisition of McDonnell Douglas, the builder of the Navy's F-18, and the Marines' Harrier, makes a dark horse an even bet.
By acquiring McDonnell Douglas, Boeing suddenly moves from becoming the least experienced JSF team to possibly the most experienced.
Clearly leveled the playing field.
I'm in this job to win, and going back to
Boeing's JSF effort is led by Frank Statkis, an engineer and 30-year company man. When you shoulder the weight of a potential $200 billion contract, stress comes with the job.
A year ago I had hair and it was dark. And now I have less of it, and it's a race to see what goes gray versus goes away. What's our G2 on the other guy?
While Statkis runs the project, he isn't the creator of Boeing's design. These days, with the complexity of fighters, no single person can claim that role.
State-of-the-art fighters. They're all designed now by computers, and these are big teams of engineers who sit down, you know, and do these CAD/CAM drawings. It's very tough to find, you know, one person who can sit there and tell you that I designed that airplane.
At the heart of the Boeing design for the JSF is a large delta, or triangular wing.
It's an unusual approach, but the big advantages of that are that it's structurally simple and that it contains an enormous amount of fuel.
Though there hasn't been an American fighter built with a delta wing since the 60s, the design has its advantages. The fastest jet ever to fly, the SR-71 Blackbird, has a delta wing because it decreases drag at supersonic speeds. The space shuttle is also built around one because it provides great lift. But neither the shuttle nor the SR-71 are exactly agile. A Delta design pays a price in speed when executing turns. And the control surfaces near the tail don't have the leverage to turn the plane sharply. European designers have overcome these handicaps in their new fighter, the Typhoon, by adding canards near the front of the plane. But in the U.S., Delta fighters have been out of favor for decades, until the JSF picked the Boeing design as a finalist. Why the new interest? Deltas can be cheap to build.
Boeing took a step back and said, what makes aeroplanes expensive? How can we leave it out? And they got a very, very simple design.
Boeing's expertise in wings has kind of taken a different tack. Our engineers have chosen to build this wing as one piece from tip to tip. We have always studied the idea of building a one-piece wing and attaching the fuselage to the wing. And so this time we had an opportunity to really try it.
Boeing has taken to heart the JSF concept, meeting the needs of the Air Force, Navy, and Marines through a versatile common design. And it even accommodates the biggest JSF challenge: landing like a Harrier. While it gets a bad rap for safety, the Harrier is no doubt the most adaptable fighter ever built. Matching its capabilities will drive many of the design decisions of the competition. When fully loaded with fuel and bombs, a Harrier takes off in as little as 500 feet, a third of that needed by most fighters. That short takeoff distance makes many roads into potential runways. After an attack, it returns, a lighter fighter, ready to execute its trademark Buck Rogers move. A Harrier hovers using rotating nozzles that direct engine exhaust downward. This mode of flight, called direct lift, demands an enormous amount of power. And it's dangerous. Before computer control, balancing a Harrier on its own engine thrust was like trying to sit on a geyser. Even today, its accident rate is 4 times that of a Navy Hornet. But through their flexibility, Harriers have proven their value. In fact, in the Gulf War, Harriers flew more missions than any other kind of fighter. For the British, the Harrier remains essential. British aircraft carriers are smaller than their American counterparts. The Harrier's short takeoff ability overcomes the problem and creates a portable fighter force.
The Harrier has allowed the UK basically to be where it couldn't be. The Falklands was a classic example. I mean, without the Harrier, we could not have defended the Falklands. We couldn't have got any aircraft down there. But the ability to put a reasonably competent combat aircraft onto a deck and get it down there and then fight was just the difference between success and failure.
But the Harrier can't fly supersonic, a serious limitation in a modern fighter.
In terms of its turn performance, its range and endurance, its maximum speed, whichever metric you want to look at, it fares unfavourably with any modern aeroplane.
We also have brothers in arms with the US Navy, so from the Americans...
The British search for a replacement Harrier brings them to the JSF table. They become full partners. It's the first time a foreign government has been included in an American fighter development program. The addition of the British only heightens what many consider the central technical challenge of the JSF competition: landing the fighter vertically. Alternatives to the Harrier's direct lift system have been studied by both contractors, but Boeing has come to a surprising conclusion.
Over the years, all contractors have looked at all of these various lift methods, and the least impact of the design always and has been direct lift.
The Boeing lift system is basically the modern version of the Harrier. Taking the engine thrust and putting it through a pair of nozzles that direct it downwards. The advantage that Boeing has is that you basically strap on the lift module around the engine, so the changes are pretty minimal.
The fewer the changes between the Marine fighter and the other versions, the better the bottom line. Boeing has made an ally of affordability.
So I believe when we're all finished doing a flight test, we'll have proven that direct lift offers the absolute greatest affordability because of the greatest commonality.
While direct lift is affordable, other parts of the plane must pay a price. For balance during hover, the engine must be in the middle. That leads to a gaping inlet to feed it air. To some, Boeing has designed a plane only its mother could love.
It's a strange-looking aeroplane. It's short, it's squat, the engine's in the front, not the back. It has this huge air inlet in front that reminds me of a hippopotamus.
This is a fighter competition, not a beauty pageant. But there is an adage in aerospace that if it looks right, it flies right. And appearance may be a deciding factor.
Appearance aside, Boeing's proposal is a cunning entry for the JSF competition. Throwing over fighter tradition, the company delivers a radical but simple design that promises to be cheap to build. Boeing's ready to give its aerospace opponent a flight to the finish.
When I daydream, I see it hovering, I see it taking off from airfields, I see it operating around the ship, and sometimes I even see it shooting down the Lockheed airplane.
Only in your dreams is the likely response of Lockheed Martin, America's largest defense contractor. For decades, in this secret facility in California, the legendary Skunk Works, Lockheed has designed and built aircraft that have blown through the boundaries of imagination.
The Lockheed Skunk Works reputation is founded on its ability to put together a small team of very motivated people, get everybody else out of the way, and leave them to solve a problem that everybody else thinks can't be solved.
The whole history of this place has been, there is nothing that we can't do, there is no project that we can't accomplish. There's a huge amount of pride of we can do anything.
We've done that. We've done that.
By the time Lockheed earns its place in the final JSF competition, Chief Engineer Rick Rezebek and his team have already spent 5 years designing their fighter. Now they must build a pair of test planes in just 2. If Lockheed wins, their work will live on for decades. If it loses...
The stakes are horrendous on this. This program will end up running from today out through the year 2050. Long after my retirement, the performance of this team and the decision-making that goes on during these next 2 years are very key.
The mystique of the Skunk Works remains unrivaled in aviation. It's the birthplace of America's first operational jet fighter, the P-80. In the 50s and 60s, this covert design house created the ultimate spy planes for the CIA. A high-flying U-2 and the high-velocity SR-71 Blackbird. Later for the Air Force, it built the F-117 Nighthawk, the first stealth fighter. Unveiled to the public during the Gulf War, the Nighthawk was the only U.S. aircraft to strike targets in downtown Baghdad. The image of anti-aircraft guns aimlessly blazing away at invisible attackers is a surreal salute to its success, and that of the Skunk Works.
They've conducted many of their most advanced programs in complete secrecy, such that nobody else in the world even had a clue what they were up to. It's got to be very, very scary going up against those guys.
The F-117 sacrifices speed and handling for stealth. It's been superseded by the current gold standard of American fighters, the F-22 Raptor, built by Lockheed. While very expensive, and not the all-in-one fighter for the JSF, the Raptor provides a wealth of proven design ideas, including a radical new shape for stealth. It's no surprise the Lockheed design for the JSF inherits the Raptor's contours. Built around one common airframe, Lockheed's proposed fighter is modified for each service. Most visibly, the Navy model has a larger wing and tail for carrier landings. The exterior design of Lockheed's fighter holds few surprises. On the surface, it looks like the company doesn't want to gamble. It's on the inside for the Marines' vertical landing requirement that Lockheed's bet the farm. The company's gone with a daring new propulsion system known as a lift fan.
The lift fan has been an engineering challenge because there has not been a lift fan built before.
In the lift fan design, the engine sits in the usual fighter position in the tail. A drive shaft connects it to a large fan placed behind the pilot. To hover, engine exhaust is directed downward. But the fan is also engaged, taking in air from above the plane and blowing it out below. That creates two balanced sources of thrust, potentially a more powerful and stable arrangement than the Boeing solution. But to accomplish this feat, the drive shaft must be spun at an incredible rate.
Think of taking the propulsion system in a Navy destroyer, shrinking that down into a smaller package, putting it into a jet fighter airplane.
It's a technological challenge in the tradition of the Skunk Works. If successful, the lift fan will be revolutionary. But on the drawing boards, it doesn't blow away its critics.
It's a very clever solution, but it's got gears and bearings and a lot of moving parts. And in an operational airplane, you've got to make sure they work 100% of the time. If you're a pilot hovering at 50 feet and one of those parts fails, it's going to spoil your day.
Despite its complexity, the lift fan offers another benefit, invisible to the JSF sensors and test equipment, but plain to the naked eye: aesthetics.
You can look at the Lockheed Martin airplane and say, that looks like what I would expect a modern, high-performance, high-capable jet fighter to look like. You look at the Boeing airplane and the general reaction is, I don't get it.
Lockheed will build its test planes the same way it's built its successful prototypes of the past, as handcrafted machines, here in the Skunk Works. This facility provides a well-worn path to winning the JSF competition. Lockheed will try to triumph through daring new technology,
just like Legos,
while Boeing tries to win with a bold, cost-saving design combined with manufacturing know-how second to none.
You couldn't have a more interesting competition. Two very different companies, two very different designs. A conservative heavyweight against a radical newcomer. If Lockheed wins, it continues its decades of fighter manufacture. If Boeing wins, it could go on to dominate the fighter market like it dominates the airliner market.
I think we'll look back at this time, at this competition between Boeing and Lockheed, and I think it will be remembered as the Great Fighter War.
The next battle of the fighter war will feature close combat. Less than a mile away from the Skunk Works is Boeing's top-secret complex, the Phantom Works. And these two classified installations, the JSF competition is ready for takeoff. The schedule will be fierce by aerospace standards. In 24 months and on a budget of $1 billion, each company must build and fly not one, but two experimental planes. Adding to the tension, Boeing and Lockheed will remain in the dark about each other's progress. Nova is among the select few cleared to enter both facilities. Its footage locked away each night by security personnel. Boeing may not have built a fighter since the 1930s, but from day one, the company rolls out innovations to simplify the job. This scaffolding holds the parts as they arrive. The team uses lasers to position each component precisely in three-dimensional space, without having to wait for surrounding pieces. The parts themselves are designed so precisely that they fit together like puzzle pieces, with hardly any adjustment. Techniques like this lead Boeing to claim it can reduce assembly costs by as much as 75%.
It's a very interesting process, very new. Boeing's ability to demonstrate how the aeroplane is put together is certainly a plus, and that will weigh in their favor.
The frame for the single massive delta wing, the heart of the Boeing design, is already in the works. But the skin that will cover it is being cooked up over 1,000 miles away at Boeing's headquarters in Seattle.
After we put the pad up on, we'll probably need to cut it.
Engineer George Bible has spent the last year experimenting with a revolutionary material for the surface of the wings. It's a resin and carbon fiber mix called thermoplastic. In small quantities, it's been used on fighters before, but no one has ever tried to create anything as large as a 30-foot wing skin.
It's very challenging. We have no time or schedule to design something else, so we have to make it work the first shot.
Thermoplastic wings will be lighter and more durable than conventional wings. There may even be other undiscovered benefits, according to another engineer who first experimented with the material in the 80s, Frank Stadkus.
I personally would love to have thermoplastics on this airplane because I know that there's value in the future. Even though I can't tell you in all the areas where we might find that value, I do know it's there.
The future, in a word, thermoplastics. But right now, George Bible needs to solve some pressing problems. Making thermoplastic begins with these sheets of graphite, also known as carbon fiber, the same lightweight material used in fishing rods and tennis rackets. For the wing, it's laid down up to 90 layers deep on top of a giant metal mold, or tool.
We take layers of these graphite fibers and set them on top of each other, and then we put the resin in between to hold them together.
After 3 weeks of layup, the wing skin is tightly wrapped in protective bags, ready for the next step. A massive oven called the autoclave. The huge chamber acts like a pressure cooker.
The autoclave for me is always the most stressful part. You have nightmares at night thinking about all the terrible things your autoclave could do to it.
First, all oxygen will be removed to prevent a cataclysmic explosion. Then, with the wing heated to the melting point of lead, nitrogen will be pumped in, raising the pressure and exerting tons of force upon the thermoplastic, forcing the fibers to blend with the resin. In short, this is literally hell on earth. For the next 30 hours, George Bible will hold his breath until the cooked skin is removed from the autoclave and a perfectly formed wing skin is revealed.
Oh, she looks beautiful, doesn't she? Looks good. Looks very good.
But this skin is only the first. Boeing will need 3 more, one for each side of its 2 delta-winged X-planes. And although Bible is elated at his success, he knows that the next skin, for the lower wing, will be far trickier. It involves a more complex curved shape. And, in fact, when the next skin emerges from the autoclave, the first signs are ominous. Creases and folds on the surface hint at hidden structural flaws.
Man, that does not look good, those wrinkles. I'm afraid we're dead in the water.
An instrument scans the surface of the panel using water and sound waves to probe for air pockets that could fatally weaken the wing.
When we have a gap in the plies, the sound will not transmit through there well.
George Bible's worst fears are confirmed. The skin is riddled with defects.
Right now, I'm just exhausted. We can't get a break. I mean, it's just downhill. So we'll have to do what we have to do to get a panel down to Palmdale as fast as we can.
After hundreds of hours of work, the wing skin is worthless. With the first wing frame nearing completion down in Palmdale, Bible's team and its bold experiment are simply running out of time. Lockheed is facing a crisis of its own. The problem that has brought its entire assembly program to a grinding halt hinges on the holdup of a single crucial part.
We can have 99% of everything it takes to assemble the airplane, but if there's one part that hasn't been delivered yet and it's buried somewhere in the middle of the aircraft, you have to wait on the assembly work until that actually shows up.
Like Boeing, Lockheed engineers have tried to save money by reducing the number of parts needed to build the plane. One part in particular, Bulkhead 270, has ended up especially complicated. It will join the front of the plane, including the cockpit, to the fuselage. As a key piece holding the plane together, it's made of the metal alloy titanium. The combination of strength and lightness make it a natural choice for the bulkhead. But nobody at the Skunk Works had anticipated how hard it would be to carve such a complicated piece out of this super hard metal. Machining the 300-pound Lockheed part means whittling away at a solid 5-ton slab, the drills running 24 hours a day, using diamond bit saws and a special lubricant to reduce heat. The pressure to get the bulkhead done is enormous, but so is the price of any mistake.
If this part fails, it could almost ultimately be the end of our competition with Boeing in the JSF program. I mean, it would really set us back.
On top of the crisis on the shop floor, bad money management threatens to get Lockheed fired from the competition. In a program in large part about affordability, the company admits it's $100 million over budget. Lockheed blames part of the overrun on a $30 million accounting error.
In essence, what it was is we were writing checks without going back into the check register is what it amounted to.
Lockheed, yes, had a problem in the subcontract management business in their manufacturing end at Palmdale. It wasn't discovered till late. Very unfortunate, very disappointing. And the lesson there is, take nothing for granted.
It's a make or break point in the program. Under a powerful escape clause, the government can end the competition and award the fighter contract to Boeing. In the first real test of the military's commitment to fiscal limits, the JSF lets Lockheed off the hook. They're saved by the growing number of international customers now lining up to buy the Joint Strike Fighter.
We got Canadians, we got Italians, we got Danes, we got Dutch, we got a little bit of everybody. It ensures that for tomorrow in coalition warfare, we got partners with the same capability to fight the same wars as we do.
Ending the competition early would be a domestic and diplomatic debacle.
The government realizes that this program is so big and so influential on a national and, in fact, international level that their best bet is effectively to sweep this anomaly under the carpet. Let's forget about it and let's move on, and let's work under the assumption that Lockheed has learned a lesson and they won't let this happen again.
Although as disappointing as that was, the silver lining there is we're doing business a lot better and will continue for the future.
In the end, Lockheed gets slapped on the wrist for bad budget controls and presses on with the program, nearly a year and a half behind schedule.
We can't let 1 minute go by without paying attention to something out on the floor and getting it done. We can't be slackers anymore.
But back at Boeing, it's hardly been smooth sailing. The latest results from computer simulations are pointing to an alarming conclusion. Boeing's entire delta wing design may be fundamentally flawed. The Navy has refined its requirements and wants a more maneuverable plane that can carry more weapons. Boeing's delta wing design is now seriously overweight. Months into building the test planes, Boeing's lead engineers conclude that the only way to lose the pounds is to abandon the delta and come up with a new wing and tail design.
We are at a point in the process here where we need to make a decision on the tail. I think we're really struggling with which way to go.
An engineering team led by Dennis Muhlenberg must come up with a new tail design that will work on a reconfigured fighter. The conventional choice is called a four-poster for its 4 control surfaces, the tail design for all modern U.S. fighters, including Lockheed's Raptor and its proposed JSF fighter. But there is an experimental alternative, a novel 2-post tail with just 2 angled control surfaces. The Pelican tail is named after its inventor, an engineer inherited from McDonnell Douglas, Ralph Pelican. He argues its merits.
Sure, I understand you're all nervous about this new concept. I think it can be done.
Proponents of the Pelican tail argue that the design is less visible to enemy radar. In other words, it has a smaller stealth signature. For Boeing, this is an important plus, since Lockheed is the originator and acknowledged master of stealth technology.
We can't afford to have any question at all over our signature and whether we're making a signature.
I don't think that we really know enough about the Pelican tail. You know, we think we can make it work, but how much effort is ahead of us to make it work?
Those supporting the traditional 4-post tail argue it's a known quantity. The word on the street is that the JSF program managers favor it for the same reason.
There's a slight benefit from a strategy standpoint that we can negate a perceived Lockheed advantage by going to a 4-poster. On the other hand, we end up looking like the follower with 2 teams that have the same design.
I vote for the Pelican tail. I think we've got to bite the bullet and go there.
I guess maybe I'm still more conservative than Fred, and I would stick with the 4-poster and try and get the signature to work with the airplane with a 4-poster.
But your probability of getting hit...
The room is deeply divided.
I'm talking about if you have a failure.
In the end, Muhlenberg must break the tie.
Now, I've been a 4-poster fan up until about an hour ago. All right? I think we can beat the pants off Lockheed when it comes to working weight, handling qualities, aerodynamics. Whether it's real or not, they're perceived to have a signature advantage. So we need to do something to our configuration that will give us a signature advantage. I think the Pelican tail does that. All right?
Feeling pressure to make a bold choice, Muhlenberg chooses the Pelican tail.
About some things, so let's go figure out how to make it work.
But just days later, after Frank Statkus and senior management review the choices, Boeing changes its mind. Concerned about weight and performance, it commits to the more conservative 4-post tail.
Is signature versus weight. The 4-poster is a little safer way to go. So I was a little torn from a personal standpoint, but when we stood back and looked at the data, I think we made the right decision.
Boeing radically changes the wing and tail design, which gives the proposed fighter a fresh new look. The new plane is projected to be 1,500 pounds lighter and more agile. But it's too late to incorporate the design changes into Boeing's 2 test planes, now 8 months into assembly. Instead, the company will submit the new configuration with its final proposal. By testing the new design in simulations and wind tunnels, In flight testing the old design, Boeing believes it can prove the soundness of its approach.
To those of us watching JSF from the outside, this is the first sign that all is not well with the Boeing design. Both designs are evolving as the requirements evolve, but it seems that Boeing's design is not as adaptable as Lockheed's. The requirements are still evolving, so there must be concern within the government that Boeing's design can keep up.
There was a lot to be made of the fact that their design was all screwed up and that they couldn't fly and they couldn't do this and they were behind and so forth. Not the case at all. To me, it was just an improvement in their design according to the requirements. It was very normal. Very, very normal.
Whatever the future holds for the redesign, at least one of Boeing's nightmares is finally over. George Bible's team has finished the troublesome wing skins and is ready to rush them from Seattle to California. The last pair of panels is loaded onto a C-5 Galaxy, the largest cargo jet in the Air Force.
Boy, I hope the wind doesn't tip her wing over.
Bible scrapped the temperamental thermoplastic and cooked up the wing skins from a more conventional composite. Though heavier and less durable, the new wing coverings are finally on their way to Palmdale, still more or less on time and on budget.
And that's just what happens when you're reaching in technology. Sometimes you're successful and sometimes you're not.
Emotionally, it'll be over for me when I see that airplane disappear over the horizon heading south.
With the wing skins safely in Palmdale, Boeing wastes little time attaching them to the wing box.
Whoa, hold it.
But before the upper skin can be mated to the structure, critical wiring must be installed.
Let's go terminate.
A lone electrician crawls in between the skin and wing box to connect wiring. Working in the dark under the 700-pound wing skin is a grueling job.
I'm gonna need a heat gun.
Hour after hour,
Doing good.
wire after wire. Each connection is tested and double-checked.
How you doing, Lonnie? Almost done. You almost done? Yeah. How many connects you have to do? 2.
He's been in there for 4.5 hours. Has not come out yet. It's dedication. Now here he comes. See if his leg's still moving. All right, Lonnie, my man.
You ready to clear, Jack?
With the wiring done and the skin lowered into place, mechanics will spend the night hand-tightening thousands of fasteners. Before the wing can be mated to the aircraft, another major piece must first be attached to the fuselage. Like a giant gift, the entire front end of the airplane arrives in the Phantom Works hangar.
Now the work begins.
Can't believe my eyes. Oh, waited for all this time and finally got it. I can't wait to hook it up.
The front end, which includes the cockpit with all its intricate electronics, was built in St. Louis at a former McDonnell Douglas plant, now part of Boeing.
Bring her back another 3 inches.
But will this front end, built 1,800 miles away, made up with the rest of the fuselage? The fit must be as precise as the width of a human hair.
If we bring this down a little further, we'll get the fleshness a little bit better. Yeah.
Both up together. Bring her back just a little bit more. Bring her back about a 1/2 inch and we're there. Looking real good. That's good. That's good.
In less than 2 hours, the installation is complete. And the Boeing X-plane has its distinct face.
It's starting to look like an airplane. That's what's really neat about it.
No, I see a future contract.
Well, that too.
With the addition of the one-piece wing, an apparition appears at the Phantom Works. The recognizable outline of the first of the Boeing X-planes. The company is now weeks ahead of schedule, and morale couldn't be higher.
It went great. Looks like an airplane now. Look at it. Lockheed, watch out.
We're here today to announce the largest acquisition program in the history of the Department of Defense.
Roger, copy.
The Joint Strike Fighter.
And just for the record, pilot, yes, you are my hero.
In the skies over the Mojave Desert, a battle of X-planes has begun.
That looks good.
Over the next year, 2 different planes will take to the skies again and again on a relentless quest to be crowned the fighter of the future. Perhaps the last manned fighter the U.S. will ever build.
Oh, it smooths out beautiful. This is fun.
Great, it was super, yeah. Thank you very much.
So awesome.
Oh, it felt great.
We're going to fly the out of this airplane and just kick every day. That's what it's all about.
It's all part of a top-secret competition, locking 2 of America's aerospace giants in a furious engineering dogfight to the death.
You couldn't have a more interesting competition. 2 very different companies, 2 very different designs. Conservative heavyweight against a radical newcomer.
We got a hell of a smart team, so let's go figure out how to make it work.
Whoa.
There's never really any time to relax.
Would I like to be further ahead? Yes. Would I like to be farther done? Yes.
I think we truly believe that we've got the right vehicle for the customer.
It's starting to look like an airplane. That's what's really neat about it.
Oh, I see a future contract.
Well, that too.
Not just any contract, but the most lucrative contract in military history. At least $200 billion.
Steering is off.
And the winner won't be just any fighter. It will need to land on a carrier, evade enemy radar. This is the battle to build the fighter of the 21st century. In the first strike in the war on terror, fighters are the frontline warriors. Navy fighters joined squadrons from the Air Force and the Marines to attack Taliban and Al-Qaeda positions in Afghanistan. These aircraft play a key role in routing the enemy, just as they did in the Gulf War in the early 1990s. In fact, some of the fighters are literally the same planes. Built in the 80s, designed in the 70s, to fulfill Cold War objectives from the 60s. The most important weapon in America's arsenal is based on ideas almost a half-century old.
Our airplanes, they're wearing out. They're tired. 30-year airplane, still a great airplane, service purpose as well, but it's old.
These aircraft in the future battlefield, they're going to be a bit like dinosaurs. Not just in their sort of physical age, but their electronic capability. They may not be survivable.
We now have to go to higher altitude instead of lower altitude. We need to make ourselves as small as possible from a radar perspective. We have to do the same job, but the world has changed.
Almost all of America's fighters will one day wind up here, at the boneyard at Davis-Monthan Air Force Base in Arizona. Old generals may fade away.
Television.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support NOVA.
And by the Corporation for Public Broadcasting, and by contributions to your PBS station from viewers like you. Thank you. Inside this bag is the future of American fighter power.
There will probably never, ever be another program as complex as this or as big as this when you start talking about dollars.
It's called the Joint Strike Fighter Program. For 5 years, the JSF has held a competition between two titans of aerospace to see who will build the next generation fighter. It's a prize worth up to $200 billion. And the winner's name is in the bag.
The winner of the JSF competition is going to dominate the fighter aircraft market, not only here in the United States, but worldwide.
Fasten your seatbelt and put up your tray table. Nova and the Department of Defense have cleared you to enter places where cameras have never gone before. From secret installations to the cockpits of the latest experimental fighters, you've landed in the classified world of the X-planes, both high-tech and handcrafted, where pilots fly into the unknown with just you by their side. But old fighters are cannibalized for parts. The Air Force still relies on thousands of these. The venerable F-16. But the F-16 is past its prime. In the age of stealth, this fighter shows up on radar the size of a small, flying house. This is an F-18, the mainstay of the Navy. But Navy planes get old fast. The controlled crash, known as a carrier landing, and the rapid acceleration of a catapult launch will eventually create irreparable stress fractures and send them all here. This is the subsonic AV-8 Harrier jump jet, flown by the Marines. While it remains the only successful vertical landing fighter, it dates back to the British invasion of America by the Beatles. Though later refined by McDonnell Douglas, by any measure, the Harrier is ready for retirement. The goal of the Joint Strike Fighter program is to replace all of these: the F-16, the F-18, and even the vertically landing Harrier.
It is absolute vital necessity to have not only a replacement airplane for the older airplanes, but to have an airplane that's a 21st century airplane to meet the needs for tomorrow.
The plane for the 21st century, at least for the Air Force, would appear to be already here. The new F-22 Raptor, scheduled for deployment in 2005. The Raptor is the ultimate fighter. So stealthy, its radar signature isn't much bigger than a bird. And it can fly at supersonic speeds longer than any other fighter, hover like a helicopter.
But trying to build a fighter that can do all three is a tremendous challenge.
It's not a natural thing for a jet airplane to do.
Come on, Simon.
Experimental new designs come with their share of risks and failures.
402 left to the downwind.
But now the U.S. military desperately wants a winner, claiming that aging fighters and shrinking budgets threaten to undermine its command of the skies.
Going to 76.
Will a one-size-fits-all fighter, a joint strike fighter, work for the Air Force, the Navy, the Marines? Will it rescue them from the death spiral of defense costs? With unprecedented access from the Department of Defense, Nova's cameras take you into the U.S. military's most classified facilities. From the beginning through repeated trial and error.
Can I reset? Negative. We're recommending we abort.
The original design wasn't gonna hack it.
How much effort is ahead of us to make it work?
Watch two teams struggle to get their daring ideas off the drawing board and into the air.
The Joint Strike Fighter will be the world's premier strike platform. With a decision to proceed now made, it is now appropriate to announce the winner of the Joint Strike Fighter competition.
In the end, only one winner takes all. In the Battle of the X-Planes. Up next on Nova.
Major funding for NOVA is provided by the Park Foundation, dedicated to education and quality television.